Hello everyone. In this video we're going to be solving a functional system, sort of. We have f of x and we have f of g of x, which is the composition of f and g. Remember, composition is not commutative, so f of g and g of f are usually different things. So our goal is to find g of x from here. So we have the composition of f and g, and we have f. Let's go ahead and find what g is. So here's what I'm going to do. I'm going to start with f of x and use it to evaluate f of g of x. Now, what does f of g of x mean? It's also written as f composition g of x, which means that replace the x, and I know this is kind of a little confusing, replace the x in f with g of x. So that's what we're going to do. Everywhere in f of x, we're going to replace x with g of x. And that gives us the following. F of g of x equals, on the right hand side, I get g of x minus 1 divided by g of x plus 1. Now, if I knew what g of x was, I could easily substitute and find f of g of x. But in this case, it's kind of like reverse engineering. We are given f of g of x. We are supposed to find g of x, or an expression for g from here. Okay, what can we do about this? Well, we do know f of g of x, so let's go ahead and set this equal to 2x plus 1 over x minus 3, because these two things are the same. Make sense? Okay, great. So now, here's what we have. We have this equality, and we are going to solve for g of x. So I'm going to show you two different approaches to this, even though you may not consider these two methods, because we're basically going to be solving for g of x. How different can it be? But I want to show you a little longer method first, or approach, and then another approach which has a name, by the way. Anyways, let's get to it. So let's go ahead and cross multiply. I'm going to multiply g of x minus 1. So let me write it as a product first, okay? This times x minus 3 is going to equal g of x. Oh, that's like a really bad g. Okay, g of x plus 1. Sometimes, I don't know why, but Notability does that. Just messes up my writing. Anyways, okay, so let's go ahead and distribute here. G of x times x. I can write it as xg of x. And just continue to distribute. I don't have to, explain everything here. I think you guys are smart, so you can get this. Okay, the left-hand side gives me this, and the right-hand side, if you distribute, you get 2x g of x, and then plus g of x, plus 2x, plus 1. Awesome. So now, speaking about smart, I hope I didn't make any mistakes. Anyways, so this is what we get from here. We got this, and we got that. So they're like terms. We got this, and we got that. They're like terms. What should we do? Let's go ahead and put everything that contains g of x on the right-hand side, and then everything else on the left-hand side. How about that? So I'm going to go ahead and subtract this. That's going to give me xg of x. I'm going to bring this 3g of x over here as a plus sign, so that's going to be plus 4g of x. So these are taken care of. So underline so you know what you've taken care of. And everything else is going to be on the left-hand side. So I got to send these over there. That's going to become negative 2x, but negative x minus 2x, that's going to become negative 3x. And sorry, I'm switching sides here, so hopefully this is not too complicated. I know the way I do it is kind of complicated, but bear with me. And just, that's what you get. Okay? What am I going to do from here? Take out g of x. Factor. Factoring is super powerful, very helpful, and good and fun. So, from here, we can get g of x, provided that x does not equal negative 4. Of course, it shouldn't be, right? There's some domain issues here. So divide, and you're going to get the answer, g of x, right? Really? That's the answer? Yes, of course. We got the answer. Wow, that's surprising, right? It shouldn't be. So we basically solve for g of x from that equation. Easy, right? Simple. So I call this reverse engineering because it wasn't as easy as replacing something with something and then just simplifying it. We kind of had to solve for it. So let's go look at the second approach. And the second approach has a special name. It's called Componendo dividendo. I really like the way it sounds. It's kind of fun. But anyways, this is how Componendo dividendo works. I want you to know how it works before I get into it. So if you have a over b equals c over d, then this implies a plus b over a minus b. Notice what I did to a and b. I can do the same thing to c and d, and these two are still going to be equal. This is very easy to prove, by the way. You can do it. If you replace a with bk and c with dk, and you can just go ahead and plug it in, and you're going to see that these two ratios are actually equal. Now, what is so significant about this? Like, why are we making a big deal out of the componendo dividendo? Because I think it's a big deal. First of all, I have to tell you that. So don't underestimate the power of componendo dividendo. Okay, I just like saying it. Anyways, so here's what we're going to do. Look at this and look at that. Can you apply this rule here? Of course. Look, suppose this is A and this is like B. So I'm going to go ahead and add them up. So A plus B, right? Divided by A. Can I do that down here? Because I don't think I'm going to have enough room there. So let's go ahead and scroll down, and A plus B. I'm not using parentheses. I hope that makes sense. And then at the bottom, I have A minus B. Okay. And that should equal C plus D divided by C minus B. This might look complicated first, but once you get the hang of it, it's going to be really easy. And the cool thing about that is this gives you g of x directly. Look at that. -1 and +1 cancels out, and then g of x cancels out, and then we end up with the following. 2g of x on top. At the bottom, we're going to get -2. And on the right-hand side, we're going to get 3x minus 2 divided by x plus 4. This is a little different than what we got because we have a negative sign. Cross these out. We're going to get a -1 sign here. So it's going to make negative g of x equals 3x minus 2 divided by x plus 4. And remember, our original answer was different because now we have to negate both sides, meaning that we're going to multiply both sides by -1 to get g of x. Okay, so if you do that, now there's different ways to do it. You can multiply the numerator or the denominator, but I like multiplying the numerator by -1. It just looks better. I don't like to see a negative sign at the bottom. Anyways, that's a preference. And then you'll get g of x from here. So hopefully you enjoyed Componendo dividendo. Please let me know. This brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.